All right, you guys, so here is extension 10.1. So this is just a 1 page worth of notes here, and we are gonna rationalize the denominator. So that's gonna be our main goal. We're gonna mainly work on these example ones. We'll talk a little bit about example 2 right here, but I really just want you guys to get comfortable with the example 1. So I'll give you some practice problems with that. So to fill in the blanks here, so when a radicand in the denominator of a fraction is not a perfect square. So remember all those perfect squares that we talked about, like 4, 9, 16, 25, 36, on and on. So when we know that the denominator down there isn't a perfect square, we're going to do this. We're going to multiply the fraction by an appropriate form of 1. And that's going to eliminate the radical from the denominator. This process is called rationalizing the denominator. So we're going to look at example 1. I'm going to then give you a bunch of other examples that you could try, and we'll do those together as well, and then we'll move on. So here is example 1. Let's look at it right here. So when we simplify this, we can rewrite this. So instead of saying the square root of 1/3, we're going to rewrite this as the square root of 1 over the square root of 3. And we want to rationalize the denominator, so we want to get the square root of 3 to become some rational number. And the best way to do that is you're going to multiply this fraction right here by a form of 1. Now, a form of 1, there's so many different forms of 1, but we want a specific one. So we're going to look at what our denominator is, and we're going to take that and say, okay, we're going to multiply it by the square root of 3 over the square root of 3. This right here, right, the square root of 3 divided by the square root of 3 is a form of 1, because any number divided by itself always gets you 1. So we're multiplying this. When we do this, we multiply across, because we're multiplying fractions. Square root of 1 times the square root of 3 is you really just do 1 times 3. You just multiply those radicands. That gets you the square root of 3. And that's okay to have that now up top. That's fine. The square root of 3 times the square root of 3 is really just doing 3 times 3. Multiply those radicands and you get the square root of 9. So now this has helped us get a rational number down here, because if we simplify this even further, we know that we have a perfect square down here now, which we could keep this as square root of 3 up top over the square root of 9 equals 3. And right there, you just rationalize the denominator. This is our final answer, and we're going to leave it like that. So I'm going to give you some examples, and then we're going to work through these together, and then we'll move on after that. So I'm going to give you 3 more examples. So I'm going to flip this over. You can do this on like a separate sheet of paper. So here are my examples. Number 1 is 1 over the square root of 10. Number 2 is going to be the square root of 2 over the square root of 7. And then number 3 I'll put down here is going to be the square root of 9 over 2. All right, so all these look a little bit different. So I'd encourage you to stop here, try to rationalize the denominator, and then press play and see if you did it correctly. So for number 1, if I'm going to rationalize that denominator, I'm going to multiply that by a form of 1. So I'm going to multiply it by, the form of 1 that I want to multiply by is that denominator, the square root of 10 over the square root of 10. And when you multiply across right here, 1 times anything gets you that number, so it's going to be the square root of 10 up top. And then square root of 10 times square root of 10 is, remember, you multiply those radicands by each other, so it's going to be the square root of 100. And this helped us get a perfect square down here. So this square root of 100 becomes 10 now, so my final answer, square root of 10 stays up top, over the square root of 100 is 10. And you just rationalize the denominator. For number 2, I want to get, this is not a perfect square down here, so I want to rationalize the denominator, so I'm going to multiply by a form of 1. The form of 1 is going to be that square root of 7 over the square root of 7. When I do that, we multiply across. And again, you're multiplying the radicands by each other, the 2 times the 7, and just leaving the square root with it. So it's going to be the square root of 2 times 7, which is 14. And 7 times 7 down here is 49. So the square root of 49. I can then simplify that just a little bit more and say, all right, it's the square root of 14 over 7. And that I then just rationalize the denominator. For the last one, number 3, I would rewrite this as the square root of 9 over the square root of 2. I can then simplify that a little bit further because I see that, oh, the square root of 9, that's a perfect square. So I'm going to say 3 all over the square root of 2. And then I have to rationalize the denominator. So I need to get rid of this non-perfect square down here. I multiply by a form of 1. Square root of 2 over square root of 2. Multiply across. 3 times the square root of 2, we can just leave that as 3 times the square root of 2. And then square root of 2 times the square root of 2 is the same thing as saying 2 times 2, which is the square root of 4. And that equals 2 down below, right? So we just rationalize the denominator. So 3 times the square root of 2 all over 2. And there is your answer. So that is just rationalizing denominators just for these simple problems. If you want more practice problems, I definitely can give you more. I'm going to move on to the next example. So I'm going to flip it back over. And we're going to go to example 2 now. So it looks a little different. I'm going to rewrite this one out. So 1 over 3 plus the square root of 5. And we're still going to want to multiply by a form of 1. But in this case, we're going to multiply, since this is an expression down here, it's not just a square root. We're going to multiply by what we call a conjugate. And a conjugate is just basically, this is 3 plus the square root of 5. We're going to multiply by the form of 1 of 3 minus the square root of 5. 3 minus the square root of 5. And so this is still a form of 1, right? An expression divided by expression. If it's the same expression divided by itself, it's a form of 1. But just the key here is just making sure you have opposite operations here. And watch what happens when we do this. So we're still going to multiply across, right? 1 times 3 minus the square root of 5. We know when we multiply 1 by anything, it's just going to get us itself back. So we'll see that 3 minus square root of 5 is still up top. But watch what happens here. I can multiply these numbers by each other right here. So it's going to be 3 times 3, which is 3 squared. Minus square root of 5 times square root of 5 is going to be square root of 5 squared, right? Because we're just multiplying square root of 5 by itself. When we do this, we can then simplify this down here a little bit more and say, oh, that is 9 minus, and then the square root and the square, they cancel each other out. So it really becomes 9 minus 5, because the 5 is still there. And then up top, right, if you multiply the 1 by both of these in here, it's still going to get you that 3 minus the square root of 5. And then finally, to get my final answer, 3 minus the square root of 5 stays up in the numerator. 9 minus 5, we can simplify to 4. And you just rationalized and simplify this radical expression. So again, the key thing here is the conjugate, right? Taking this addition sign and making it a subtraction sign. If it was a subtraction sign here, the conjugate would be then the addition of that. So the last example here for our extension is they just are talking about the distance in miles. D, that you can see to the horizon with your eye level h feet above the water is given by D equals the square root of 3h over 2. How far can you see when your eye level is 5 feet above the water, right? So what you're going to do is we're going to take this 5 and we're going to replace h, because h is talking about the feet above the water, and put it within this expression. So this is going to give us our distance. So it's going to be 3 instead of h, 5 all over 2. I'm going to simplify 3 times 5, so this is really saying 15 over 2. And now we just go back to that first example. We need to rationalize the denominator here, because this is really saying the square root of 15 over the square root of 2. So we have a non-perfect square down there in the denominator, so we're going to multiply by an appropriate form of 1. which in this case is square root of 2 over square root of 2. Multiply across. 15 times 2 is 30. 2 times 2 is 4. And then we're almost here. So now we have that perfect square down below. That's what we wanted. And so our final answer is the distance that we can see is the square root of 30 over 2. And this is miles. Let's put here, miles. And again, we could then type that into our calculator, but they just want us to rationalize. So that is rationalizing the denominator. That's the extension. If you have any questions, please email me, or you can comment on the Google Classroom. Or this video, I'll see if I can figure out how to comment back on the video. I'm sure it's pretty easy. All right, so have a good one. Bye.